This is our introduction to exercise 2G on inequalities on page 111. So for this exercise, as I mentioned earlier, it's an optional. It will come up in assessment, but as a bonus. Otherwise, you're welcome to work on your other exercises. So in this case, we've got Greg, Kevin, and Greta who think they have the correct solution to this inequality. Greg says x equals 4, Kevin says x equals 10, and Greta says x equals to 100. Now, typically speaking, if I give you a linear equation, and I say, for example, let's say I say x minus 2 equals to 6. You know, normally you'd say we're going to x minus 2, we're going to plus 2 on both sides, and we get x equals to 8. How can we check if x equals 8 is correct? If it's a linear equation, perfect. I just put my answer back into this one here. I'd replace x with our final answer. Now, normally speaking, 8 minus 2 equals 6. That is correct. Let's try to apply the same understanding for these solutions here. If x equals to 4, 4 times 4 is 16. 16 minus 1 gives me 15. I'm going to keep that symbol there. And then on the right-hand side, I've got 4, because x is replacing 4. 4 plus 6 gives me 10. What does the symbol right here represent? Of course, it's the same as we've done in previous years. The quote-unquote alligator eats the bigger part, so therefore it means it's greater than. The line on the bottom means or equal to. So it's saying 15 is greater than or equal to 10. Is that true? It's true. Therefore, that is a valid answer. But you'll probably note, if I substitute something else, it might still give me a valid answer. If I put x equals 10, 4 times 10 is 40, minus 9 is 30, so minus 1, is 39. On the right-hand side, I put in 10. 10 plus 6 is 16. I do the same symbol. Is that a valid statement? It is. 39 is greater than or equal to 16. Inequalities means that instead of it being equal to one thing, it could be a few things. Okay? So let's see what that looks like. Graphically, this is what it would look like on a linear line. Inequalities can represent an infinite number of numbers. We use an open circle if we're not including, and a closed circle if we're including. I'll explain what that means in a second. So open when it's not including, closed when it is including. Let's say I wanted to show on a number line which goes from, let's say, 0, 1, 2, -1, -2. Let's say I was trying to sketch where x is greater than 2 but less than or equal to 3. Of course, there's a difference there, isn't it? This one right here means it's not including. The one on the right-hand side means it is including. So on my number line, I know that x is anything between 2 and 3. I'm going to go from 2 to 3. And I'm going to draw a line in between. Now, in this original one, it says x is between 2 and 3. But this line on the bottom means we're including 3 as well. So I'm going to fill that circle in. You can see how x can be any number between 2 and 3. It could be 2.00001, but it cannot be 2. Because it specifically says here, x is greater than 2, which means we don't include 2. Okay? This one right here, that's what we call the upper bound. So that would be the upper bound, and this one here would be the lower bound. They're just names for it. Okay? Now, we're going to go through some examples. Linear inequalities can be solved the same way as linear equations. The only difference is that if we divide or multiply by a negative number, we flip the sign. That's the only difference. If we divide or times by a negative number, we flip the sign. So let's first look at what things would look like on a number line, and then we'll go ahead and try to find the answer. The first example here says show each of the following examples on a number line. X is less than 4. It's already given us this inequality right here. X is less than 4. So on my number line, I'm going to start from -1, -2, -3. I'm going to keep going to -4, -5, and I'll just stop there for now. Now it says X is less than 4. Are we including 4? We're not. So I'm going to go up to, and apologies, I should have gone this way towards 4. There we go. I should have gone this way. So we have 4. It says X is less than 4. So I'm going to draw a circle. It's an open circle because we're not including 4. And it needs to be less than 4. So I'm going to draw an arrow this way. So X does not equal to 4. We use an open circle. That'll be this answer here. Now for the next one, it says X is greater than or equal to -3. So I'm going to use a dot at -3. It says or equal to. So I'm going to use a closed dot to represent it can be -3. It says greater than or equal to. So greater than, of course, is more positive. More positive means we go to the right. And it should look something like that. That would be this answer here. Any questions about that? Okay. Last thing we're doing is solving for the answer. Find the solution set for each of the following inequalities. That should be inequalities, one word. X minus 2 is less than 9. If this was X minus 2 equals to 9, you would be very clear in saying just plus 2 on both sides. So you'd end up with X is less than, we keep the sign the same, 11. On the right hand side, this one's a bit trickier. So if this was 4 minus 3 3x equals 7, the first thing you do, you might minus 4 on both sides. So I'll minus 4 here, and I'll minus 4 there. Are we multiplying or dividing by a negative number? No. We're just minusing for now, so we're just going to keep it the same. Those cancel out, we get -3x. Instead of writing equals, I'm going to use that sign they gave me, and 7 minus 4 is 3. Here's the tricky part. Now, if this was equals, what would we do? What would we times or divide by? It's -3x, it's 3. We're going to multiply or divide by what? So it's -3 times x. What you might decide to do is divide by -3. It is a tricky one, but we can divide by -3. When we divide by -3, because we're dividing or multiplying a negative number, what do we do to the symbol, to the sign? We flip it. So these two cancel out and we get x. And instead of it being greater than, we're going to go less than. On the right hand side, 3 divided by -3 is -1, and that would be our answer. Any questions? What are our questions? Okay.